Welcome back to Digi Net Academy. In our last episode, we explored the concept of a repeater, how it regenerates weak signals to help them travel longer distances. If you missed it, do check it out to understand the basics of signal amplification. In today's video, we are moving one step ahead in the network device family and learning about the hub. A hub is a basic network device that connects multiple computers or devices in a local area network. It works at the physical layer, or layer 1, of the OSI model, just like the repeater. Now here's something important to note. A hub is a non-intelligent device. It cannot analyze or make decisions about the data it forwards. It is a plug-and-play device, meaning you don't need to configure anything to get it working. Also, hubs do not have memory. They do not store MAC addresses or any forwarding tables. Instead, they act as a central connection point. When one device sends data, the hub copies and sends it to all the devices connected to it. This is called broadcasting. Every device receives the data, but only the intended device accepts it. The rest discard it. The main function of a hub is to create a common connection point for devices in a network. A hub typically has 4, 8, 12, or 24 ports, depending on the size. When data comes in through one port, the hub duplicates the data and sends it out through all other ports. The hub does not analyze or manage the data traffic, it just repeats and forwards it. Here's something important. When we use a hub, all devices share the same collision domain. This means if two devices send data at the same time, their signals can collide and cause errors. However, all devices also share one broadcast domain, meaning when one device sends a broadcast message, all devices receive it. So, the hub cannot reduce traffic or isolate problems. Everything is shared. Hubs were commonly used in small office or home networks in the early days of Ethernet. They are simple and cheap, which made them popular for learning and small setups. However, due to their limitations, they're not used in modern networks anymore. Today, hubs are considered outdated. That's because modern devices like switches and routers are more intelligent. They reduce collisions, increase speed, and improve security. Unlike hubs, switches send data only to the intended device, not to all ports. This makes modern networking much more efficient. Let's take a quick look at some advantages of hubs in networking. First, they're simple and easy to set up. They're also inexpensive, making them a budget-friendly choice. Hubs can be great for learning environments or small experimental labs where basic connectivity is enough. And the best part? No configuration is required, just plug and play. But despite these positives, the disadvantages of hubs are quite significant. They create many collisions because all devices share the same communication domain. There's no traffic control and no built-in security. A hub broadcasts data to all connected devices, which leads to network congestion. And finally, it can't prioritize or manage data, which makes it inefficient for larger or modern networks. So, while hubs are simple, they're rarely used in today's advanced networking setups. In short, a hub is like a group announcement. One person speaks and everyone hears it. But in a smart meeting, the speaker talks only to the right person. That's what switches and routers do. Hubs helped us build early networks, but today we use more efficient devices. In the next video, we'll talk about bridges, how they connect different segments of networks and filter traffic smartly. If this video helped you, please like, share, and subscribe to Digi Net Academy. Click the bell icon